Hi students, in this video we are learning about the sine rule. So students, after watching this video you should be able to describe how the sine rule relates to ratios of sides and angles in non-right angled triangles. So we're now starting to work not just with trigonometry of right angled triangles but also trigonometry of non-right angled triangles as well. You should be able to describe when the sine rule can be used and what conditions need to be met to use the sine rule, and also calculate unknown sides or angles using the sine rule. Right, so some things you have to recall. You have to be able to recall mainly how to rearrange equations, and then how to label not all the sides of a right angle triangle, but in particular the opposite side when looking at a reference angle. Right, so since broadly speaking, trigonometry is not just the study of right angle triangles, but all types of triangles. So to this point, we've only really been using trigonometry for right angled triangles. Now the sine rule that we're learning about here can be used to calculate unknown sides or angles for non-right angled triangles, really broadening our understanding of trigonometry so we don't need to keep using right angled triangles the whole time. We can now start to use trigonometry on non-right angled triangles too. So let's consider the following triangle. Notice that we've got vertices A, B, and C. They're all in capital letters. And the sides opposite them have the same letter, but in lowercase. Lowercase b is opposite vertex capital B. Lowercase a is opposite vertex capital A. Lowercase c is opposite vertex capital C. And that's really important in terms of notation and using the sine rule formula. Now the sine rule states that the ratio, so ratio, we're talking about fractions, we're talking about division, the ratio of each side of the triangle to the sine of the opposite angle is equal. It's a lot to take in. Right? The ratio of each side of the triangle to the sine of the opposite angle is equal. So what that means is, in terms of a formula, is the length of A over sine A is equal to B over sine B, capital B, equals little c over sine capital C. Now, it's also true if we flip all the fractions over. So sine of capital A over little a equals sine of capital B over little b equals sine of capital C over little c. So that ratio, that fraction, is going to be equal for any opposite side and angle. And that means we can use this formula to work out sides or angles, as long as we know one side, we know the length of one side, and we know the opposite angle. If we don't have that opposite angle and side that we know the value of, then we need to use another rule. But if we do know the values of that opposite angle side pair, just in one situation, just one matching pair, we can use the sine rule. Now the sine rule can be used for both acute and obtuse angled triangles. In this video we're going to deal just with acute ones, and in the next video, looking at the ambiguous case, we'll look at some obtuse angles as well. Now with our sine rule, my biggest tip is to put whatever your unknown is in the top and the numerator of your fraction. So if you're looking for an unknown side, put the unknown side in the numerator, use this left-hand side of the formula. If your unknown is an angle, use the right-hand side of this formula, because the angle's on top. Basically, it just makes it easier to rearrange. All right, so in this first example, we've got to calculate the value of x in the diagram below. So we've got x here, and we know its opposite angle over here, 42. Now the big giveaway here that we're going to use the sine rule is the fact we do know an opposite angle and side pair. So we know the angle 85 up here, and we know the opposite side, 15.3 meters. So because we know that opposite pair, that's a big giveaway to say we're going to use the sine rule. Now in this one here, we're looking to find a side, so it makes sense to put our sides on top in our sine rule. So a over sine A, I'm going to say it's going to equal b over sine b. And substituting those values in, we'll have 15.3 over sine 85, and that's going to equal x over sine 42 degrees. Now to rearrange that, we're just going to multiply both sides by sine 42. That cancels, so all we're left with is x equals 15.3 sine 42 degrees. Because it's multiplication, that can just go up to the top with our numerator, all over sine 85 degrees, which equals 10.28 meters. Just putting that into our calculator. And again, that answer seems reasonable because smaller sides, like x, should be opposite smaller angles. So 42 is a smaller angle than 85, so x should be a smaller side than 15.3 because smaller sides are opposite smaller angles. So this answer does make sense. All right, in this next one, we've got to calculate an angle this time. Once again, we've got an angle that's unknown, and this time we know the opposite side, 13.1 centimeters. We also know our angle, 72 degrees, and the opposite side. So because we know that angle and opposite side pairing, that's a big giveaway to say we can use the sine rule. This time, because we're finding an angle, I'm going to put the angle on top. So sine A over A equals sine B over B. So sine theta over 13.1. So our unknown is on top and the opposite side is in the denominator, equals sine 72 over 22.3. Now rearranging this by multiplying both sides by 13.1, those cancel. Sine theta equals 13.1 times sine 72 over 22.3. Once again, multiplying means we can put that in the numerator. And then, to get theta on its own, we'll just use sine minus 1 of 13.1 sine 72 over 22.3 into our calculator, and that gives us 33.97 degrees. And there's our angle in our triangle. Alright, so after watching this video, students, you should understand how the sine rule relates the ratio of sides in a right angle triangle, in a non-right angle triangle that is. You should be able to recall and describe when the sine rule can be used, which is when we know an angle and the opposite side, then we can use the sine rule. And then calculate unknown sides or angles using the sine rule. We covered that in our last two worked examples.